Now let me discuss this integral by 6 methods. Six methods. So the methods is important in discussing here. Now, method 1. Now I start with the easy ones. Method 1, that using substitution, let x be tangent t. Right? Then the integral becomes natural log 1 plus tangent t. Right? And this will be tangent square plus 1. The derivative dt will be dx will be secant square t dt. Now and then here tangent square plus 1 is secant square, so it can be cancelled out. And when x equal to 0, t is 0. When x equal to 1, t is a quarter pi. So my integral becomes from 0 to quarter pi. After cancel secant square, it becomes a natural log 1 plus tangent t dt. Okay, good. Now, this formula I've used quite some in my previous videos, and even proof. And the proof is very easy. You can do it by yourself. So here I'm applying this formula. This will be equal to from 0 to quarter pi, and natural log 1 plus tangent a plus b. I mean quarter pi, right? Quarter pi minus t and dt. Yeah, this one is equal to 0 to quarter pi, natural log 1 plus, right? 1 plus, right? This tangent quarter pi minus t is 1 minus tangent t over 1 plus tangent t, right? And the dt, yeah. So that would end up with the 0 to a quarter pi and the natural log 1 plus tangent t, 1 plus tangent t 2, there, right? Dt. Okay, then we can use a property of a logarithm. This becomes 0 to quarter pi log 2 dt. That's the first one, minus natural log 0 to quarter pi natural log of 1 plus tangent t dt. So this one is equal to that. See, this one is equal to that. Therefore my I, this is my I, right? Just start from I. Therefore, this is I. So I is from equal to 1/2 quarter pi log 2. Yeah, this is equal to 1/2 1 quarter pi log 2. and equal to pi over 8 log 2. So that is my result of this integral by method 1. Yeah, good. Now method 2. Well, method 2, I start using same substitution. Let x be tangent t. So my integral becomes from 0 to quarter pi, and natural log 1 plus tangent t. This is tangent square t plus 1. Dx would be secant square t dt, right? Then cancel with this one, and then you get quarter pi natural log 1 plus tangent t dt. Okay, now here I'm using sine over cosine. Right? This is cosine. This is cosine plus sine. No, t, right? Well, let me change it to x. All right, these are just dummy variables. Now, then sine plus cosine. Well, sine quarter pi plus x, according to the trigonometric, this is equal to sine quarter pi, which is 1 over root 2 times cosine x plus sine x times 1 over root 2, right, for cosine quarter pi. So this one equal to 1 over root 2 sine plus cosine. So sine plus cosine is root 2 times sine quarter pi plus x. So this one is equal to, from 0 to quarter pi, natural log root 2 times sine quarter pi plus x dx, right? Yeah, over x, over cosine x. Okay, good. Then I'm using this formula again. Okay, this one equal to 0 to quarter pi natural log root 2 dx. That's the first one. Second one is from 0 to quarter pi log sine quarter pi plus x dx minus 0 to quarter pi log cosine, right? Log cosine x dx. Okay, which means log this one plus log that over log that. Okay, that means 3 integrals. Now this one is equal to log 2 quarter pi log 2, right? That this integral. This integral, I'm using this property equal to natural log sine quarter pi plus quarter pi minus x dx, right? This one using this property, this, and minus 0 to quarter pi natural log cosine x dx. And this one, log root 2 is a half log 2, right? So this is 8 pi log 2. And this one is equal to half pi minus x is cosine. Log cosine x dx minus log cosine x dx. So these two can be cancelled, plus and minus. So this is equal to pi over 8 log 2. So that is a second method. Yeah, the third method, method 3, start with the substitution. Okay, let x be 1 minus u, 1 over 1 plus u. And my dx will be using quotient rule, right? Quotient rule. This one square, and this derivative is a negative, then this one minus this derivative times this one. So it's end up with the 2 du. Okay, good. So my integral becomes when x equal to 0 is 1. When x equal to 1, u is 0. And this would be natural log 1 minus u, 1 plus u, plus 1 over 1 minus u, 1 plus u square, that is x square, plus 1, right? Multiply the dx. Dx is negative 2 du over 1 plus u square. Well, just simply substitution. Nothing strange. So this one equal to, now this negative I switch the boundary, right? So 0 to 1. So this negative is gone. I'll leave 2 outside. This 2 get out. And this becomes a log, log 2 over log 1 plus u. Now this is 1 plus u over 1 plus u. So end up with the 2. And the du. This one time this one is a 1 minus u square. This one time this one is a plus 1 plus u square. Good. This is just simple algebras. And then this one equal to 2, well, 2 integral, and this one is equal to log 2 minus log 1 plus u, isn't it? U. This one is at 2 plus 2u square, right? The midterm canceled out. The midterm is being canceled out. So it becomes this one. Yeah. So this one is 2 cancel out. So it becomes 2 integral the first one is 1 plus u squared du, right? And the second one is from 0 to 1, log of 1 plus u, and 1 plus u squared du. And this one is equal to, this one is easy, arctangent. No, wait a minute. I missed something. The first one is log 2, right? Log 2, yes. Log 2, I'm sorry. Log 2, I'm missing 2. This is log 2, the coefficient. So log 2 times the arctangent u, right, from 0 to 1. That is this integral. And this one is my target integral. The same thing. Yeah, just dummy variables. This is I. Huh? So I is equal to 1/2. This is log 2 times quarter pi, right? Excuse me, I always just 1/2 log 2 times quarter pi. Yeah. So I is equal to pi over 8 log 2. Yeah, excuse me for my clumsy writing. So anyhow, this is a method, method of what? Method of 3, right? Now, okay, method of 4. Well, the fourth method, I start with by parts. Now, this one is equal to from 0 to 1, natural log of x plus 1. Dx over x squared plus 1 is d arctangent x, isn't it? Yeah. Now, this method is not that easy. This one is equal to natural log x plus 1 and arctangent. Let me slow down a little bit. From 0 to 1, that's uv, right? Minus vdu. vdu. V is this, arctangent. Du is 1 over x plus 1, dx. Yeah. And then this one is equal to, this is a quarter pi, this is log 2. Quarter pi log 2. Now, for that one, for this, I'm using substitution. Well, I let x be tangent half t. So half t is equal to arctangent x. I let x equals tangent half t. The half t is arctangent x. Then this is for that, right? Let me change the boundary first. When x equal to 0, t is 0. When x equal to 1, that will be half pi. T will be half pi, yeah. Then this is equal to tangent half t plus 1. I have to work out carefully. This arctangent is half t. This is arctangent x. Dx will be what? Dx will be secant square half t times half, the chain rule, right? Times dt. Okay, good. I have to work carefully. Okay, so this is pi over 4 log 2. Now, this is 1/2. There's 1/2. This becomes 1/4, right? 1/4. From 0 to half pi. And this is what? This is 1 over cosine half t, right? This is 1 over cosine half t. If I multiply both numerator and denominator by cosine square half t, so this will be gone, right? This is t left and dt. I multiply cosine square half t. So this will be left is a sine half t and another cosine, right? Half t plus cosine square half t. Wow. I hope you follow that. Now then, this one equal to 1/4 pi log 2 minus 1/4 0 to half pi. This will be t dt. Now this is equal to, this will be what? This will be 1/2 sine t, right? This is equal to this, just using double angle formula. Plus this one is half 1 plus cosine t, right? Yeah. So this one equal to 1/4 pi log 2 minus 4, and the 2 cancel out, becomes half. Yeah. Integral from 0 to half pi. Yeah. 2 is out. Is 1 plus sine t plus cosine t, right? Yeah. This is t dt. Wow. It's a little better. Now I'm using the formula again. This formula is really, really useful in definite integrations. So this one equal to 1/4 pi log 2 minus 1/2 integral from 0 to half pi. I'm using this formula. So this will be half pi minus t dt. This will be 1 plus half pi minus t is cosine. Half pi minus t is sine. So actually the denominator is not changed. The numerator is. The numerator is changed, but not denominators. So log 2 minus, so I have two integrals, right? The first one is a 1/4 pi, right? 1/4 pi this one times this one, right? From 0 to, and dt, and 1 plus cosine t plus sine t. And the other one become plus, right? Half integral 0 t dt, right? It's a 1 plus cosine t plus sine t. Wow, very good. Now check this formula, check this line and this line and this line, right? Check this equation rather. That means this one, let me use them this way, okay? This is actually equal to that. Obvious, right? They're equal. This, is, therefore this is cancelled out. This and that, same thing. See, this and this, same thing. Therefore, if you move this over there, then this will be equal to this. Therefore, how, 0 to half pi t dt 1 plus cosine t plus sine t is equal to 1/4 pi of 0 to dx 1 plus cosine t sine t. Oh, well, I hope you understand that. Now from this and that, they're equal. So if I move this one over there, becomes minus this, right? Is equal to this. That's why this is equal to that. Then see my integral I. My I is equal to what? Is equal to this one times this. See, my I is equal to this minus a quarter times this. This is equal to this. So is that? Well, then therefore my I is equal to 1/4 pi log 2. That is this one. Yeah, 1/2, right? Minus 1. This is from I, right? This is I. I equal to this minus 1/2 times this. This is this. So 1/2 would be eighth. This and dx dt 1 plus cosine t plus sine t. Well, I hope you're not lost. Let me slow. My I is equal to this. And this is equal to that. This is equal to that. If I replace this one there, is equal to this. See? Now this type of integral we can do using this method, right? Let half tangent, right? So let me use another variable. So how about the x? X equal to tangent half t. Then you have a sine x and cosine x dx, right? So you know what is sine x, what is cosine x, and what is the dx. Now, you have done this method many times, I believe. So this could be done like this, minus pi over 8, and 0 to half pi. No, not 0 half pi. When when t is half pi, x is equal to 1. So I'm sorry, this is 1, 0 to 1. And dt will be 2 dx over 1 plus x squared, right? 1 plus, this cosine is 1 minus x squared over 1 plus x squared, plus sine is 2x, 1 plus x squared. For this type of substitution, you must be familiar with. Then this simplify again, minus pi over 8, and from 0 to 1. And if this can be simplified by multiplying 1 plus x squared, so I end up with the 2 dx and 2 1 plus x. So this is cancel out. This is equal to quarter pi log 2 minus 8 pi, eighth pi log 1 plus x. X is from 0 to 1. So this is equal to 8th minus 8th pi log 2. So they end up with 8th pi log 2. That is the result by method 4. Okay, it's some steps. Okay, now this method 5. Method 5. Well, method 5, I'm using the double integration. Now from 0 to 1, x dy, 1 plus x y. For this integral, we're integrating with respect to y. So x is a constant. So this one will be equal to, from 0 to 1, d 1 plus xy. 1 plus xy. We treat x as a constant. And then this will be equal to log 1 plus xy from 0 to 1. Okay, x is constant, therefore this is equal to log 1 plus x. What I want to say is this: natural log 1 plus x, natural log 1 plus x dx is equal to this. Okay, so this one is equal to 0 to 1 and 1 plus x squared plus 1. That is this one. And log x is this, is integral from 0 to 1 x dy, 1 plus xy, then dx. That is what I meant. Okay, so this is double integral x squared plus 1 times 1 plus xy and x, dx dy. So we can change the order. This is okay. If I want to do dx first, then well then this we can use partial fraction. So this one is equal to x square plus 1. This is a x plus b, right? Plus c 1 plus x1 and dx then dy. If we integrate with respect to x, then here y is just constant. Okay, then let me omit the detail to determine a and b, c, right? These just straightforward, very easy to do. I shouldn't say very easy, but rather could be easy, could have obtained by using comparing the coefficients, right? So a is equal to, there's no room for it, but anyhow, I'll write this way. A is equal to 1 plus 1 over 1 plus y squared. That's A. B is equal to y over 1 plus y squared. That's B. C is a negative y over 1 plus x y squared. Okay, this is x squared plus 1. This is 1 plus x and dx and dy. See, well, this rational function, if I consider y is a constant, when integrate with respect to x, y is a constant. Therefore, we can do this one as a partial fractions. See, this is quadratic, therefore this is ax plus b. This is linear, so is a number on numerator. Then using the comparison, the coefficients, we determine a and b and a c. A is a 1 over 1 plus y squared. B is a y over 1 plus y squared. C is a negative y over 1 plus y squared. So, excuse me if omit that the detail finding ABC, right? But you can do it very easily. So we find this one now, and then we integrate. Then we integrating this with respect to x. So y is a constant, right? How many okay, this over this. Y is a constant. So y is constant, right? So this equal to, let me write this way. Okay, 1 plus 1. Yeah, I have a double integral. I omitted that one. Sorry, I miswrote this one. This is 1 over 0, okay? Now, this is double integral. Yeah, this, I'm sorry, this is already doubled. This is doubled. I hope you understand my miscopying. Okay, this is double integral, right? Double integral, you have a 2 integral sign. Okay, double integral. Now here, I do this integral. This integration is equal to 1/2 log x squared plus 1. X over x squared plus 1 dx is this. Because x is 1/2 dx squared plus 1. So it becomes log, right? Is from 0 to 1. And minus, no, plus, sorry, plus this one. Plus y1 plus y squared, that's constant, arctangent, x. This one. This over that integral is this, respect to x. Huh? And then minus, this is a constant, right? So this one is equal to 1 over 1 plus y squared log 1 plus xy. Well, all together, dy. Wow. Now this is the integral of this one with respect to x. Eh? Yes, correct. Yes, it's correct. So this one is equal to 0 to 1. This will be log 2, right? This is log 2, yeah. This will be 1 over 1 plus square. This is half log 2. Log 2. Plus, this is quarter pi. 1 plus quarter pi. And this is 1 minus 1 plus y squared log 1 plus y. Right? Then dy. Yeah. Okay. This integrate with respect to y. This is half. Right? It's not clear. This is a half log 2. This integral is arctangent. Y from 0 to 1. Okay. That is this one. For this integral is equal to quarter pi. And this integral is a 1/2 log 1 plus y squared, right? 0 to 1. 0 to 1. Minus this integral is same as my target integral, I. So this is I. This integral with respect to y is the same as this integral with respect to x. They are same integral. So my 2I is equal to, this would be quarter pi, right? This 1/8 pi log 2. That is this one. 1/8 pi. And this one is log 2, right? Log 2, 1/8 pi plus 1/8 pi log 2. Therefore, I is equal to 1/8 pi log 2. Yeah. Wow. What a method. Well, anyhow, I got it. This is method 5. Now, method 6. Method 6. I'm using a Feynman treatment. Let f of a is equal to integral from 0 to 1 log 1 plus 8x and x squared plus 1 dx. Well, I then my I is what? My I is equal to f of 1, isn't it? When a equal to 1 is my target integral. F of 0 is what? F of 0 is log 1, is 0, 0. Okay, good. Then uh, the derivative of f with respect to x, with respect to a, I'm sorry. The derivative of f with respect to a is a partial derivative with this one, right? Is equal to partial derivative of that integral function. This will be equal to, I'm talking about the derivative with respect to a, yeah? So this will be equal to x squared plus 1 and 1 plus ax, and a chain rule, right? You have x on top. Wow, good. Then we can use partial fractions, right? This is x squared plus 1, ax plus b plus c 1 plus ax, right? dx. And then let me omit the details to find ABC. You must be familiar with this, right? A okay. Let me write. A is equal to 1 plus 1 over a squared. B is equal to a 1 plus a squared. C is equal to negative a 1 plus a squared. These just, well, algebraic work by comparing the coefficients. So therefore, my f derivative a is equal to integral a and b, right? Is 1 plus a squared multiplied by x plus a x squared plus 1. That is this one, huh? Yeah. And dx. This one. And the plus. No, a is negative, right? C is negative. 0 to 1. The a. Yeah. 1 plus 1 plus a squared and dx over 1 plus 8x. 8x. Okay, that is this one. Okay, good. Then integrate with respect to x. A is constant, right? So the first integral is a 1 plus a. This integral is 1/2 log x squared plus 1. That is the integrating with respect to x over x plus square. Okay, that is this one. X over x squared plus 1. That is this. And from 0 to 1. Huh? And for this integral is 1 over 1 plus a square arctangent. There's a here. There's a here. Arc x over 0 to 1. Okay. Yeah. And for this integral, this is a 1 plus a square. This is 1 over a log 1 plus 8x from 0 to 1. From 0 to 1. So this one is equal to, this is equal to 1 plus a square. This is a half log 2 plus this is a 1 plus a square quarter pi. That is this one. For this integral is a minus a cancel out 1 plus a square and log 1 plus a. Wow. Okay, that is the left hand side is f derivative, right? F derivative with respect to a. So then I integrate this. I integrate both sides. Integrate from 0 to 1, the whole stuff. The whole stuff, right? Let me save writing this here, okay, with respect to a. This is f derivative of a with respect to a, okay? So how to find f of x, f of a? We integrate both sides, right? So this side will be what? F of a, right? From 0 to 1. That is left-hand side. Now the right-hand side, I integrate one by one. Okay, this is a coefficient, right? This is arctangent. So half log 2. This integral with respect to a is arctangent a, right? From 0 to 1. This integral is a 1/2 log 1 plus a square, right? From 0 to 1, yeah. That is this one. This integral from 0 to 1 is my target integral. So this is my target integral, right? There's some just say they are same, just different dummy variables. Now this side is equal to what? This side is f over 1 minus f over 0 is equal to 8 pi, right? Log 2. That is this one. This one is 8 pi log 2, right? And minus I. I know that this is what? F of 0 is 0. F of 1 is I. So this is I, right? I is equal to 1/4 pi minus I. See? Therefore, I equal to 1/8 log 2. Wow. Finally, I've done 8 methods, get same result. But if you look carefully, you can trace back all the details. And the methods, we are learning. The methods are very, very interesting. The integral itself, just the one example. The methods, 6 methods. But actually, this one, I think we may have more methods. For example, we can expand this one as a Maclaurin series. So is 1 over x squared plus 1, right? So we're using series. We may have a, we may get the same result. I'll leave it for you to explore. And well, it's today is a little longer, but I think they should be very interesting. Thank you for your watching.